Welcome back to another day.
Oh, it's no.
It's weird because for only the second time in my life, the Kansas City Chiefs are Super Bowl champions.
Ugh, obnoxious.
It is. As a Raider fan, I agree with you. We are going to pick up where we left off in class on Friday, and that is how to solve electric circuit problems. So getting right into it, I'm using a different app so I can't scroll with the pen. We want to be able to solve a circuit like this. And there are three rules we use. Number one is Ohm's law. By the way, you'll notice what we covered past and present I didn't update because it's just the last couple slides. Ohm's law. Who remembers Ohm's law? We know it three different ways. V equals IR. We're going to use this in our circuit analysis to relate current and voltage. Remember, the V is the voltage difference across a resistor. I is the current through the resistor. So for a given resistor, let's say this one right here, the current is going that direction. So which side is the positive side of that resistor? Just answer top or bottom. Which one is the positive side? The side that's the tail of the arrow is the positive. The tip of the arrow is the negative because energy is lost when we force the current to go through the resistor. And voltage is the energy per charge. So that V equals IR is our first relation. Our second one, whoops. This is not, I was wondering why it didn't look right because I had modified it. There we go. This is the one I was supposed to be on. You can see they look the same because one was the last one? This one. Just making sure we remember what I wrote. So the next one is Kirchhoff's current law. Kirchhoff's current law, that's a restatement of which fundamental basic rule?
Yes.
Conservation of charge. Conservation of charge. Charge can be created or destroyed. And since current is the rate at which charge flows, then charge flowing into a node has to equal the charge flowing out. So current in equals current out, or the way I do it is this way. The sum of the currents in a node is 0. You can use current in equals current out if that makes you happy. You'll get exactly the same answers. So just go with what makes you feel good. So that's our second rule, Kirchhoff's current law. Third rule, Kirchhoff's voltage law. What is Kirchhoff's voltage law a statement of? What simple law is that? Conservation of energy. That if you go around the loop and come back to the starting point, you're going to have the same, the net change in energy per charge is 0. You're back to where you started. So once again, I use that as sum of the voltage changes in the loop is equal to 0. You can also do it as sum of the voltage rises equals sum of voltage drops. You go with what you feel comfortable with. So given those rules, here's how we solve a circuit. So step 1, identify each essential node. So in this picture, there's lots of nodes. A node is anywhere that 2 or more elements meet. Essential nodes are the ones we actually use, and that's where 3 or more meet. So all of those are labeled A through H, I think. A through H. Which of those are essential nodes? A and E are essential nodes. Missed. Because those are places where we have 3 things that come together. So there's our first step, identify those essential nodes. Second step is identify each branch current. A branch is something that connects one essential node to another essential node. And so in this, we have how many branches, how many ways can you go from A to E? 3. So we have 3 branches. So we have 3 branch currents. And so they were conveniently already labeled 1, 2, and 3 for us. And so those branch currents go through everything in the branch. Now, when I do this, I'm going to erase what I already wrote. I go and right beside each resistor, I draw the current with the direction it's flowing through that resistor. Missed. And go above it. I do that for the express reason of the next step, and that is to identify which side is positive and which side is negative for each element. So which side is positive for R2, the top or the bottom? The bottom. Which side is positive for R1? Left. Which side is positive for R1? Dang it. I'm not sure why my hand did that, but. Which side is positive for lowercase r2? And finally, which side is positive? We already did this one for R3. I did that so when I apply Kirchhoff's voltage law, I will get my signs right. There's a reason I do this, and it's not for my own, health. It's to make sure I don't make a mistake in doing the problem. So I have identified each essential node and each branch current. Now a new word. Identify each mesh. I could have said each loop, but each mesh is a special case of loops. How many total loops could you make? That is a circuit that starts and ends in the same place. How many unique loops could we make with this circuit? 3. We have the upper one, the lower one, and all the way around. There are some rules about what equations are going to be unique. And our rule with loops is the number of unique, or the smallest number of loops that can completely cover the circuit is the number that I can use. And we call those the meshes. So I look at this kind of like I would a window. And each pane of glass, the exterior of that is a mesh. And so if I look at here, how many panes of glass would I have if this was a window? I'd have 2. And so the meshes are the upper loop and the lower loop because those are the exteriors. And I always, always, always choose the same direction to mark them. I mark them as clockwise. You don't have to. You can choose any direction you like. But I mark them as clockwise so I won't make a mistake in my application of solving the problem. The more uniform you are, the less likely you are to make a mistake. So I've identified each of my meshes, and I will give them names. I'll call this one mesh 1, and this one mesh 2. Now my preparation to solve is done, and it's time to get to solving. So I'm going to, by the way, we call this mesh analysis. There's nodal analysis as well. There's more than one way you can solve these problems. Mesh analysis is the only way we're learning in this class. If you want to learn other methods of solving circuits, take the electric circuits class that Randy took last semester. Randy has studied this stuff into the ground. So apply KCL. What does KCL stand for? Kirchhoff's current law. And what does Kirchhoff's current law mean?
The current going into a junction is the same as the current coming out of a junction when it splits.
Yeah.
That is correct. The way I wrote it is sum of the currents out of node is equal to 0. You could put sum of the currents into a node is equal to sum of the currents out of the node. Either one is the correct statement, the same law. But here's a new thing at all but one of the essential nodes. Once again, you can't use Kirchhoff's current law on every node. You can only use it on all but one of the essential nodes. So in this case, you identify 2 essential nodes, A and E. So I just have to choose one. Which node would you like to choose?
A.
Okay, A was the clear answer. So I'm going to put sum of the currents at node A equals 0. And then I just look at my figure, And when I'm doing some of the currents, it's arbitrary which way you choose. I like to choose in is positive, and that means out is negative. Yes, sir.
So it wouldn't matter which node we chose because they're all flowing through? So like,
I will do the other node and show you why it doesn't matter.
Okay.
So I'm doing sum in. So which currents, remember we only have 3 branch currents, which branch current or currents are going into node A? Okay, so I put plus I1 because I defined plus as in. What is going out? So I put those as minuses. Don't need to put equals 0 again. There's my equation. Now, I said I would do node E. So what's coming into node E? What's going out? You see those are, if I multiply by -1, it's the same as the equation above. And so they're not independent equations. We need independent equations to solve the set. One more thing I'll mention right here now in terms of theory. How many unknowns do I have in this problem? I'm solving for the branch current, so that's a question. How many branch currents do I have? You've already answered this, so it's just a repeat. 3. How many independent linear equations do I need to solve for 3 unknowns? Also 3. So I have to have 3 independent linear equations. Linear means it's not going to have I squared. It's not going to have I cubed or 1 over I. It's going to be I times something. So I need 3 equations that have I raised to the power of 1 for all of the i's present. So this is one independent equation. So I need 2 more. So now I'm going to go to my meshes. How many mesh equations can I make? 2. There were 3 loops, but I can only use the number of equations equal to what I have meshes. The actual rule is, as long as you cover every element in the circuit and you have the same number of equations as you have meshes, you're good. So I could, for instance, use the outer loop and one of the 2 inner loops, and that would also be a set of working equations. But since if I use all of the meshes, it's always going to be the right number of equations and they're all independent, that's why I use the meshes. So let's apply. So here I'll rewrite the equation that we had up above. Sum of the currents at A equals 0 equals I1 minus I2 minus I3. Now we're going to apply sum of the voltages on loop 1 equals 0. And so I'm going to start, remember this was my loop 1. This is my loop 2. I know it's ridiculous to rewrite all of these, but I want to make sure we don't have any possibilities of mistakes. Unless, of course, I make a mistake in writing these out myself. So I start at the lower left-hand corner. Once again, an arbitrary decision that I do for uniformity. Right? You're seeing a lot of things I do just to make sure I won't make a mistake. So I start at A, and I'm going to go clockwise. That's why I drew my arrows clockwise when I identified my meshes, because that's the way I'm going to go. So if I start at A and I go clockwise, the first thing I come to is R2. I'm adding the voltages, so how do I find the voltage based on resistance and current? Ohm's law, V equals IR. Now, is this going to be a voltage rise or a voltage drop? Drop, because it went from plus to minus. So I have minus, Ohm's law is I2 times R2. So now the next thing I come to is the power supply that's 18 volts, which for right now, I'm just going to put EMF 1. Is that a rise or a drop?
Right.
It's a rise because I went from the minus to the positive side. So plus EMF 1. Then I come to lowercase r1. Is that a rise or drop? It's a drop because I went from the plus to the minus here. Sorry. Get out of the way. If I keep going around my loop, I get to node E and keep going. I come to R1. Is that a rise or drop? Now notice this is I1 that was going through that one, so it's I1, R1. And now I'm back to where I started, so that equation is complete.
So positive to negative is a drop, negative to positive is a rise.
Correct. The same would happen in your bank account. So there's my first mesh. Going on mesh 2, I'll again start at the bottom left-hand corner and go clockwise. What's the first thing I come to in mesh 2 if I start at the bottom left-hand corner and go clockwise? R1. Is that a drop or a rise? A rise. Keep going. I get to E, come down. Is that a drop or a rise? Keep going. I come to lowercase r2, drop or rise. Okay, then finally thing, I come to the EMF 2. It's negative because it's going from plus to minus now. There's my second equation. I forgot to put sum of voltage equals 0 at the beginning, so I put 0 at the end. Question, Louis? Nope. So now I have 3 equations. 3 linear equations, because all of them have I raised to the power of 1. Independent, because my rule said that they were going to be independent. So if I have 3 independent equations, I should be able to solve these. So, let's just pick on our last teacher ride, Maxwell. How would you solve this set of 3 independent linear equations?
You know some of those.
No.
Okay, we know all the R's and the EMS, but we don't know any of the 3 I's.
Can't you just use substitution?
Okay, you can use substitution. You can take these equations and combine them to eliminate one variable and then combine again to eliminate another variable. It's kind of a gruesome process with 3, and if you had like 7 unknowns, that is unmanageably hard. And so what I'm going to teach you now is how to do this in a very simple fashion because your calculator will solve these for you. So the first step is to rewrite these equations so that you have everything that has an I on the left-hand side, everything without an I on the right-hand side of the equal sign. So I'm going to rewrite these here, not with a line, that's the line tool. Here we go. So the first one I'll write as I1 times 1 minus or plus I2 times a minus 1 plus I3 times a minus 1 equals 0. So I wrote that so my I1 is in the first position, and then I have parentheses whatever it's multiplied by, and so on. First equation was pretty simple. Second equation, I1, that was a minus sign there. I1 appears here, so I have I1 times minus R1. I'm going to substitute for R1 its actual number here. So R1 was 6 ohms. I dropped off the ohms because it's going to make my life easier. I2 was here and here. So I have R2 and lowercase r1. R2 is 2.5, lowercase r1 is 0.5. 2.5 plus 0.5 is 3, so that's a minus 3 ohms. I3, there is no I3 in that equation. So I was just going to put plus I3 times 0 equals, this was equal to 0, but I want to move this to the other side. So I have to subtract E1 from both sides. So on the other side of the equal sign, what do I have?
Negative E1.
Negative E1 or negative 18 volts. Negative 18 is what I'm going to write here. Now you do have to make sure units are consistent. If you use ohms, then you better have volts, right? If you use something else, well, make sure you're consistent. Final equation. For the final equation, I have I1 times R1, which is 6 ohms, plus I2. And what is I2 multiplied by in equation 2?
0.
Nothing. Plus I3. What is I3 multiplied by in that equation?
R3 plus R2.
Okay, I3, I'm looking at the wrong equation. R3 and lowercase r2, so that's 1.5 and 0.5, which is 2.
Where are you getting your third equation from?
This here is the third equation.
So you went 1, 2, 3, 4, 5.
Okay, so this here is 1.5 is the R3. And this here is 0.5 is the R2.
That is going to equal 45.
Okay, this was minus epsilon 2. I have to move it to the other side of the equation, so it's going to be plus, or EMF 2, I should have said. So plus 45. Now I have these equations written out in what I like to call a provocative form. It's provocative because it suggests ideas. It suggests that I could write this using linear algebra. That is, stop it here. I take this 1, put it there. This minus 1, put it there. This minus 1, put it there. This 0, put it there. 6, 3, 0, 18. You see how it goes, right? What's the difference in these equations and what we just did? Okay, it's in matrix form. Another thing is I multiplied this entire equation by minus 1. So it has positive 6, positive 3, and positive 18 instead of negatives. These are actually already available on Moodle. Oh, wait, no, they're not. They will be soon. Now, sure.
Why? Oh, wait. So your second column, your I1, I2, and I3, that's what you're looking
Okay.
for in those.
So let me explain how this works, because you guys probably aren't really comfortable with this kind of writing. This, what you have here at the bottom, is exactly the same as what's above. That is a way of writing 3 equations. The way you multiply matrices is you start at the top left of that 3 by 3 matrix, and then you multiply by the top element in the column matrix that you multiplied by. So I have 1 times I1. And then I go to the next one over, minus 1 times the next one down, I2. Next one, minus 1 times I3. And that equals whatever is in the top position in the answer. So what I have here is a matrix way of showing those same 3 equations. So this is exactly the same thing. It's just a different notation, one you're probably not familiar with. And right now you might be saying, I don't want to learn a whole new math notation. But here's what we do. How many people have a TI? Because the TI is what I'm most comfortable with at this point. If you don't have a TI, you're going to have to figure out how your calculator works. But on a TI, you turn that bad boy on. You have a matrix function. So you do second and x to the minus 1 is the key on most of them for matrices. So do second matrix, and it has 3 options: names, math, and edit. So the first thing I need to do is to create my matrix, so I'm going to go to edit. If you go to edit, it's second and x minus 1 to get matrix on. Then go over to edit, and then it has different names you can choose. Notice the names are kind of limited: A, B, C, D, E, F. Choose a name, and you need to set the dimensions. So your dimensions are going to be n by n plus 1, where n is the number of unknowns. So we have 3 unknowns, so you're going to make a 3 by 4 matrix. So I'm just going to choose A on mine, and 3, enter, 4, enter. Now I have a 3 by 4 matrix. And now I need to fill the matrix with those numbers. So notice the first 3 by 3 is the 3 by 3 matrix I have, and then the last column is the answer column. So we just smashed it together. It's a way of simplifying how we write this set of equations. So now you put in 1, enter, -1, enter, -1, enter, 0, enter, 6, enter, 3, enter, 0, enter. It'll be fine if you use it the other way as well. 6, enter, 0, enter, 2, enter, 45, enter. So you should have your matrix completely filled. It looks like everybody but Aaliyah has a calculator. You do have one in your dorm, okay. So is everyone with me, or does anyone have a question here? You don't have to do this on the test, but it certainly will help you in doing the homework and in many other applications where you have multiple equations that you have to solve. This type of question will definitely be on the test, but you won't have to solve the set of equations. What if somebody doesn't have, what if she brings that calculator to the test? I would say, ha ha,
She could solve it.
So is everybody with me? Okay, now I need to get out of this matrix so I can do math with it. So I'm going to do second quick just to get out of the matrix thing so I don't mess anything up. Now I'm going to go back into matrix though, so second matrix to get back to the matrix. But now I need to go to math. So we went over 2 to get to edit, now we go to the middle one for math. And I scroll up because RREF is near the bottom. So scroll up until you get to the function RREF.
Sorry, question.
Yeah.
Do you not have a spring 2020? He was like, I need you to ask one.
Like the videos.
Yeah.
Yeah, they should all be there.
This is
Oh,
my
I was sure I put that link in. I will go do it. Well, after class. I've been uploading them faithfully, and I thought I put the link there. Thank you for pointing it out. I can tell that my video. Well, you could go to the other ones and find it because it's just a playlist. Okay, so did everybody find RREF?
Yes.
Okay, so you hit enter on RREF, and now we have to put the matrix that we had named. The easiest way to do that is from this point in your calculator, once again, second matrix, and select the name that you just made. So I had chosen A, so I select A, and you see it just put bracket A, bracket A, bracket. And then I hit enter.
Wait. Sorry, I was explaining something to her. Could you go over that again?
We'll just show the rewind.
Right.
Okay, so now we go to matrix and choose the name you have, and then just enter.
Oh, no.
And there you have the answer. Does everybody have the answers?
What? Huh?
What?
No, she does not.
We're supposed to do 3 by 3, right?
No, 3
No,
by
it
4.
didn't say. It didn't say numbers.
So you can go to it and go to edit and change it to 4 and it'll just add.
But the 0 for the top column.
Obviously something is very wrong.
This right?
Yep.
Okay, now
But it's Amber's number?
Hers not so much. Yours is right.
What did I do?
Let's look at your matrix.
Oh, perfect.
And just do names A. No, that works too. Okay.
Yeah.
1 minus 1 minus 1. What's your? Well, let's
60.
Yeah, let's look at our answers column.
Oh, were we supposed to put those in too?
It's 0, 18, 45.
Yikes.
Yeah.
Okay, that makes sense. No, it's for my last matrix that I did in calculus.
Okay.
Oh.
So now we have the math on this. So you did RREF and it gave you that. Everyone has that, right? I think I checked with everyone. So what does this mean?
Does that mean that I1 is 4.75?
That's exactly what it means.
I2 is negative 3.5?
if we decompose it, this is showing the same set of equations. So it's I1 times 1 plus I2 times 0 plus I3 times 0 is equal to 4.75. Or in other words, I1 is 4.75. I1, or I2, excuse me, is minus 3.5. I3 is plus 8.25. Now I want you to notice something important here. Not only did we find these, actually that was real simple to find them, right? Once you have the equations. I2 is negative. What does that mean?
It's going the opposite way.
It's going the opposite direction. But before we solved it, how did we know what direction the currents were? We chose them, but we didn't know that they were right. We just guessed. There's nothing wrong with guessing wrong. I'm like, how would you know? If you end up with a negative value, that means, oh, well, the current's going the other direction. So I1 is going the direction it shows, which is to the left. I2 is going the opposite direction it showed, so instead of going to the right, it's going to the left, which means that EMF up there is being charged, that battery is being charged rather than, providing power.
So the circuit is like, it's going this way.
Well, the actual current on the top is going the opposite direction of the I2, so it's going this way on the top.
So like,
So it's like a
the circuit's going this way, and
continuous
then it can curve either this way on the middle or the top.
Well, it was I2 that was negative, so only the direction of I2 is reversed. The other one's
I1, it can still go I1, which is in the middle, right?
Right, I1, it has to be the direction that we got because we had a positive sign. And the direction we drew has a positive sign, so it's going that way. I3 has a positive sign, so it's going to the right because that's the direction we had shown. But I2, we showed it going to the right and it's negative, so it's actually going to the right. So I1 and I2 are both going that direction, correct? So now this is what lab is all about tomorrow. So we have 18 minutes for you to do your own problem. I imagine.
Yeah.
So what is your first step? Identify the essential nodes. Then what?
Identify each branch.
Identify each branch current. And if you need help after that, ask Anna, because she has it all written out. Or I'm sure they do.
Okay, this is one. Yeah, this is when you should give us
This
a
one doesn't have
printout.
any like I1, I2.
You
should
have
give
to find
a printout of these slides so that we can understand. This is what I'm saying.
To make life simple, let's call I1 the current on the left side, I2 the current in the middle, and I3 the current on the right, just so everybody has. Just have your currents
Maybe
go.
you could write it on there.
Yeah.
Okay. I'm not putting an arrow because it's up to you what direction you choose. But have your currents labeled there with the directions you choose. If you can do this, my work for today is done. Except for with David.
Yeah.
Well, then I have more work to do with you, see?
This is our fourth year of school,
I
right?
think I want to be.
Yeah.
I think it's not my calling. This is not my calling.
There's 3 batteries. Come on.
Yesterday I got so
There are
mad.
3 batteries.
Like,
Come
you're
on.
doing this stuff, and I'm always figuring out his own copy of the homework, right? Yeah, and so I do my homework, and he does his homework, and I check our answers. He's like, I didn't know you gotta do that. I
I tried to do this.
I didn't lie. He was like, this stuff is so easy.
Wait, why did I do this? I don't know why I'm doing this.
I'm just copying everything down here. Yeah. 18 minutes later.
Two positive is the tail, negative is the head? Yes, that's right. Yeah, you need to put direction for I-1, I-2, I just want to make sure everybody has the same location for I-1,
Yeah, how do you, is there not any essential notes we don't have using this? Oh, no, it's where the 3 branches.
You have to identify them, that's right.
Okay.
Wait, that wasn't my question.
No, okay, what was your question?
So I just consider all these random directions?
Yep.
Okay, so I'll just go like this.
Okay.
And like that. So I know that this one goes to these, how do I know which type negative, which type positive?
Well, if this goes like this, then it has to go like this.
Which makes this side positive.
Right.
But then what about this side over here?
What direction did you choose?
But I know that this curve's going, how do I know this curve's going?
You choose, you choose.
But then how does this curve?
Okay. So if I have this and it's going to this, then if I want to go this way, it's like opposite.
Yeah, you means you're going up instead of down. The arrow doesn't change, the plus and minus don't change. It's just in your equation. No. That would be a problem. It still needs to be I2.
So I have to start from here.
So if we do this loop, we'd be going up this amount, down this amount, down that amount. We're doing this loop, we go up this amount, minus the plus.
The essential notes is different.
Oh, so these would still be.
Yeah, it's fixed.
How do you know it's around operation?
So the current's in the same direction. You can't change the current for solving the problem, but when you go the opposite direction, it changes plus to minus in the equation. Okay?
Okay, so here's where,
Go help him come back.
So that's also where you're gonna
Okay,
have
so
where you have to
I
decide
did
like
find
what
this
version
one
of it is.
the sum of
So we should start with
nodes
one.
where the current is right. So, like, depending on.
So
Coming in.
this is
So I start from here, so this
this
goes
is
up,
okay.
around,
Yes, ma'am.
does it go down from here, or does it go across?
Does this current go into there? Or does like this current go into there? Which current goes into where?
It
And then,
splits, so you
yeah,
don't
what
have
about
to go
going this
zero
way?
one, it splits.
So
So current one only exists from here to here.
Okay, you have to go up first.
And then
the way I
between
did mine.
here, it's current two, which you have down. So current
To
two
go
is
down.
And then what about this half?
This, this here is
But
current
you stopped
one,
already,
because this
so
is all
it's
one essential branch.
How about the?
So if you go
So go up,
This is all current three?
There. Because any current that
right
goes
that,
through here has no choice but to keep going there.
okay,
Going there.
so then how do you, where do you get the like positive negative?
So that's gonna be
Each one of these.
And then for this one,
makes sense.
I didn't realize I put this upside down. I accidentally hit the rotate button and I was like, well, I'll do that.
So this is positive and this is negative.
Oh,
I'm at the
Why?
Kirchhoffs school.
for us.
Yeah.
So which node do you have? Oh, you do, yeah. So you just say, I have
Okay.
current one is going out of it. Current two is coming out of it. Current three is coming out of it. Are you looking at your arrows?
So I said.
It's just one.
That current two is going into this
So
positive.
how I did it.
I'm wondering,
I'll
out here,
Currents like
But I don't really know what you're thinking.
yeah, I've got mine doing like this.
No, wait, Bruce.
Because it's coming out, yeah.
Fair enough. That's not the point. The point is,
That's what I said.
so how do we get?
so.
Yeah, that's the 6 next to 3 and 0, those were.
So like down.
Yeah.
This is the current I1.
It's gonna go around the outside.
And if you look at the total number.
That's not the right way, right?
So
Yes, so here you're going up through this one, you're going up through this one. So instead of it being like
Okay, so this is positive, this is negative.
When it gets to the end, it's find a negative number.
This
And
way.
what direction it is, one five is.
So then is this
Okay,
one
and it's
negative
flowing
and this one
this
positive
way.
then?
This is negative.
Okay, so then
Can you
this
explain to me
is.
why this is not negative and positive?
I1.
Dr. Webb,
I don't know.
okay, can you please explain the negative and positive thing? So if this is negative, right?
Oh,
and
the
this
nose?
current is
Or
going
you-
in direction, isn't this the negative and our
So it
positive?
goes down, left,
The
left.
tail end of your arrow is always the same. So
Oh, it
this
has
is positive.
nothing to do with anything else, so
Zero.
this is positive, this is negative.
Right.
This is
Why?
Because
Okay, yeah.
if we're doing, because I want
Like
to
that?
attach this, so much better to do here.
That's
So
how
it
it
has
works.
nothing to do with these things? What are those things for then?
Those are power supplies. That's how you say positive.
Yeah.
Okay.
So now just, I mean, here, no, here's how. So let's say we start here.
It was a good effort.
So
Yeah.
we go up this amount because that was our negative plus, right? Then we go down because it was going plus to minus. Then we go down again, we're going plus to minus. Down again, because we're going plus to minus. Down again, because we're going plus to minus. Right, so now we can just follow those signs and we know what the signs are going to be in the equation.
I don't want.
Okay, then when we start making like these things like what you did before, how do you know where to start? You start at A.
Well, those are at the node, so it's only at one location. So if you're going to do an A,
I'm doing it at A.
so is I one coming in or going out? Is it coming in, is that arrow pointing to A or pointing away from A?
It's going into A.
Okay, so you have plus I1.
But this is I1 over here.
I1, okay, anything that goes through here has to go through here, has to go through here. There's no other options, right? There's no other places for current to
Okay,
go.
so,
So it's I1 through all of these things.
and then I2 is pointing away, so it's minus
Right.
I2. And then I3 is
I should have did it.
pointing away, so it's minus.
Right, there you go.
Okay, I'm trying to do the ultra and I just go down.
I'm sorry, I'm
It's only
sorry.
in
No.
this. Okay, so
Then,
And the current is.
I'm gonna try it.
so then I guess I'm confused about the voltage back then, right?
Okay, so the way we started, and there are shortcuts you can do. But the way we started is, I started here. Looks like you started here. So if you start here, you can go this way, then you can go down, because it's going to be plus and minus. This current, which is I1, you might have resistance. And then we come here, and your current is going down here, going to the picture. So which side is positive and negative?
Like this would go up, would it be?
So that means going down,
Is it outside?
And that's what I
and that's going to be I2 times 2.
So I would just do this one like that, and this one like.
Well, you're doing one loop.
did you get it like that?
Right, but then I'll do that one, then the other question I'll do.
Yes.
Okay, okay, I think I got it. Thank you. Just do.
Why did we do that?
Ready? I heard you talking, he was wrong. I said he said a good effort, he did his best.
Is there a difference?
This topic is.
Really quick question.
Go ahead.
When you're,
Because doesn't it have to go up?
All right, took too long, right away.
Okay, this is
Okay,
where I
you
get
figured
lost.
Which question?
So look, my currents are going from 30 down to 20, down to 10.
This part, the loop thingy.
Okay.
So you can go this way, you can go this way.
So then you're applying Kirchhoff's current law, right?
Exactly. I already where one negative because it goes.
Where did you apply?
We don't have these in this one.
This
one. Okay, so we have I1 in, and then I2 and I3. So it's I1 minus. Point.
Done.
Yeah, what was your- that wasn't the question.
That was not my question. So now we're on to the next part, which is the voltage. Kirchhoff's voltage law. So then does it go 30 plus 30
Okay,
so
so
minus?
do it the way I do. We just start here. So
Would you like label each one?
this here.
No, I just printed and started with the values.
So now sum of the voltages of group 1 equals 0. And so now I'll start here. So if I go from right here, I always just start at the bottom, so I don't mess up. It's just my way. You can start anywhere. But that way I know when I'm back to where I started. So I start here, do I go up or down? So I have, that's equal to probably 30 volts. Then from here to here, is that an increase or decrease? Decrease. So minus, which current is going through here?
or
Oh, yeah.
So then these are gonna have, are the bolts gonna have like three of them because they're screening?
Resistance too.
No, you don't need to.
So they're gonna be like three of these.
100
things,
I
so it's just-
Then we come to here, we go this way, or we go up or down.
So there's not.
And then what is this current?
200, so I
Resistance. And IT acceleration. Okay, then we come to this, we're going up or down.
now.
So it's 20. It's dependent on the direction of Kirchhoff.
Okay.
So then we get to this one finally, up or down.
We're trying to do Kirchhoffs.
Yeah.
Okay.
What did you?
No.
Where did you start?
Because I one goes from here.
Okay.
Okay, so I have.
I have two.
Remember, the branch currents are going from essential load to essential load.
Oh, we didn't.
I went down.
So that's that.
I
think I have it.
multiplied by the maybe.
You got the answers?
I think so.
And they're probably gonna be ridiculous answers, because I didn't choose cherry pick numbers.
Right.
You
So.
have this one and you just go I one.
I two.
And that's what makes sense. But.
So we did, sorry, we just did this one.
Yep.
So now we're doing this one.
These are.
Why you're
Okay.
negative?
There you go. Well, then you gotta do the math.
Well,
Got
it's or
These are
negative. High.
Those are fractions because the current is positive to negative, just draw. Okay.
If it's flowing this way, then you just do,
So.
just do.
We can just skip over this guy though. This guy has to do something.
Okay, thank you. They confused me a lot.
Yes, these
So does I one have to go?
Which is fine.
So it'd be negative 200, negative 200,
It
negative
goes,
20,
it goes from essential.
negative 15, positive 30.
One next to this.
To those ones we know things. We have the part.
I3 is going for this.
I don't know.
This session. And then
I used I1.
Okay, so of course, I'll have to that, but so only.
So.
Only I1 gets it
Starting
because
with whichever
I2
battery.
ends at this node and then
Y'all, your
I1 goes this way and I2 is
one essentially between the
goes into there.
So
Yeah.
if I'm gonna go from here, I can go all the way.
I think that's how it works.
That, no, that's fine. So I1 is just from, it's just to this one?
Is this one I2?
Oh, okay.
That should be
That's the pass through.
This one is
Well, it has to go through everything like that.
this one.
Okay,
Yeah,
so
it
they
should be
minus
I3.
I1.
Because the current should end at
Minus 15.
so this right here is all I2. This right
So
here is all
This, I
I1.
want this, all this, I think.
No,
Is it like, when you totally
So that means plus 30 volts?
confused, and I said this is essential.
So that's-
How did Brandon survive that class last semester?
Then
How
do
did Brandon survive that class last semester?
I have no
No,
idea.
no, that's why I said it's called.
I know it.
Just so we can all say, I want the same value.
Okay.
Yeah, I mean, you choose the names.
Top right
Oh,
hand
Henry
corner.
George.
If it's positive to negative, it's
Yes. Like the bank account, like I
Positive
said.
10.
Hi.
Oh, is this?
Okay. So,
Thank you for
make sure you select some current and nothing.
Don't ask me.
This here, at least I know it's 1, 2, so I know that. This does. Okay, so at node A, you have I1, I2, and so it's I plus I2 minus I3. Okay, then loop 1, so you start here, you go up 30, and then for this you're gonna go down 100 times I1,
I don't even know.
and then you're going, this is going
Is it positive or negative?
down, no, up, so this is going up. To 5, sure, and then going down.
You don't have You're lucky I'm
Going
cheap.
down.
I think.
That's you're right. If you got those two right, I'm gonna do that. Mine too, I mean, because it's the same method, right?
Yes. So,
Do you have questions?
Is this still a 3-1?
I may have my other, but I don't
Yes.
know what I'm doing with the eyes and the
Can you
arms.
check this?
Because you have
Mine was like 12.
So you have.
It's like a 12 by 14.
So.
What's going
And that's,
on?
that's, it's like when you put, so you put like the numbers, like the actual values, and then you put them in the equation, and then you have the answer to the equation in the matrix.
You can
So
combine
I
them.
understand, okay, so wait, at least I
Yo,
understand
you're a genius. Yo.
that. Oh.
Chapman.
I shifted mine.
Bye.
Okay. Yeah, let's try that. Yeah.
Because we're increasing voltage. So this, the weak loss,
50.
so increase in voltage, decrease in voltage.
Okay, and then for this one, I was just reducing this.
This one I'm going to.
This is all I think, and it's going around this source. On this direction, this is positive 20.
The voltage is going up 20, that's right.
But this one was positive 200.
Well, 200 times that.
Why did
So
it
this is,
and then
so that's it. I'll put it in.
Okay, our time is up. How many people got their answers?
I'm almost there. I just need like 1 or 2.
Okay, I'm going to write David Chapman's answers down, assuming that David Chapman made no errors. Hey, David Chapman's like, what? So according to David Chapman, what is I1?
I1 is 0.0338181 repeating.
That's a drum.
033.
Yeah, 338181 repeating.
And what is I2?
I2 is 0.05963 repeating.
And what is I3?
0.02581 repeating.
Okay, so those are the answers David got. DC. I'll check and make sure they're right after class. All right, have a great day. I'll see you in lab tomorrow when we will be doing this for reals with real circuits. Hey.